What can we learn from this limit? Limit as x approaches infinity, I have 1 over x times e to the x. You know, technically you're really looking at e to the x over x. The only reason why I wrote it separately is because it can help you understand the importance behind this limit. If I evaluate those items separately, limit as x approaches infinity, I have 1 over x. I'm looking here at 1 over infinity and it tends towards a 0 by means of a horizontal asymptote. Look, here's your function 1 over x. As you're approaching infinity, you're approaching here the x-axis, which is a horizontal asymptote. It's tending towards 0, but it's not truly becoming 0. Look at the other item. Limit as x approaches infinity, I have e to the x. You know clearly this is e to the infinity and it becomes infinity. If you look at everything this way, 1 over x times e to the x, you're really looking here at a tug of war between two items. 1 over x approaching infinity is a 0. Then you're doing a product. You see there's a product between these two times infinity. You're looking at something which is tending towards 0 times something which is truly infinity. Which of these items wins in this tug of war? And you can do so by means of a derivative, a rate of change analysis. If you do the derivative of the numerator, the exponential is always equal to exponential. You do the derivative of the x function, it's equal to 1. When you put in infinity, you're looking at e to the infinity and you get here infinity. What is it telling you? It's telling you one item, which is this. The exponential is approaching infinity much faster than this x is zeroing out by means of this horizontal asymptote approach. The infinity is being approached much faster by this. Hence, between the tug of war between the 0 and infinity in this product, the infinity wins. The end result of this limit here is truly infinity. Again, remember, this was not really a 0. It was tending towards 0 by means of what you see over here, approaching horizontal asymptote. Normally, if you have something which is truly a 0 times something which is an infinity, in this particular case, you'll see a 0 to be an end result. Here we have something like it, but it's not truly that because, again, this is not truly a 0. It was tending towards 0. The infinity beat it out. Between that tug of war, the end result of this limit must be an infinity, and it will be a correct answer.